Okay, my dear students, Assalamu alaikum. Welcome to our next chapter, which is the chapter number 11 from the textbook, Bessel's functions, as you can see from here. Now, I would suggest you to go through this paragraph 11.1 and then go to my notes. Now this is my notes in which the Bessel's function of first kind written as Jnx equal to sigma s is equal to 0 to infinity minus 1 power s over s factorial into n plus s factorial over into x over 2 power n plus 2s. So this is in fact the Bessel function of first kind, which is the solution of the Bessel's differential equation as we did in the previous chapter. And so this, as I told you, Bessel's differential equation is very common in physical problems. So that's why we are going to concentrate on the Bessel's functions and the related properties of Bessel's function. We will see that this algebra which we are going to develop here is so useful in its applications on various topics. So let me go to the first property of Bessel's function. Although this page is a bit dim, but you must get the photocopy of my notes from the photostat shop and then keep it before you along with the book. Okay, so this is for the you know that Bessel's differential equation has two solutions, one with n is equal to plus n and the other with n is equal to minus n, and this is the second solution, j minus nx is equal to minus 1 power n into jnx. This is known as the parity property of Bessel's function and is proved in my notes. You can see the proof of this. So you only need to find jn, calculate jn for the particular n given in the differential equation. N is the order of the Bessel's differential equation. Okay, now moving further, here is the, let me show this from the book here, and then okay, this is what I wanted to show. This is in fact the generating function of the Bessel's function. Generating function of the Bessel's function, and here is this function. Okay, this is the equation 11.1 as shown here. If you concentrate onto this function which we have defined as gxt e to the power x over 2 bracket t minus 1 over t. Now this single function, as we will see, this single function contains all the Bessel's function as represented by equation 11.2. So you see that this single function generates all the Bessel's function. Now that is very useful function, and the proof of this is given here in the book as well. But if you want to see more detail, you can consult my notes. Here is the proof. E to the power x t over 2 into e to the power minus x over 2t as expressed in their respective series. So please go to my notes to see the derivation of of this generating function. So you will see the proof of this equation 11.2 from my notes, and so that is the first property of the Bessel's function, that these Bessel's functions can be generated by a single function, and you must remember this particular single function, that gxt is equal to this e to the power x over 2 bracket t minus 1 over t. Right. Now this next property is the parity property, as I told you before, equation 11.8. This parity property states that j minus nx is equal to minus 1 power n j nx. You can prove this property by putting n is equal to minus n into the Bessel's function of first kind and go through the steps shown here or by notes, and you will reach to this property, which is a very, very useful property again. So that you can say is the second property. Now the third property is the recurrence relation. Now this recurrence relation, there are in fact two recurrence relations we will discuss here. The first recurrence relation and the second recurrence relation, known as the recurrence relations of the Bessel's differential equation or of the Bessel's function. So what we do here, we differentiate the generating function gxt with respect to t partially and go through these steps, and which are done in detail from my notes, and reach to this expression over here, equation 11.10, that j n minus 1x plus j n plus 1x is equal to 2n over x into j n x. So after the derivation from my notes, which you must go through all these steps, and if you have any query you can ask me. Okay, so why this function is called the recurrence relation. In fact, this is a three-term recurrence relation. So as you see, for example, if jnx is given, say j2x is given, and j1x is given, so you can jump to jn plus 1, which is the j3x. Okay, so listen again. If jn is given and the previous Bessel's function jn minus 1x is given, then you can move on to the next generating function. Say starting from j1 and j2 you can find j3, and then using this equation again from j2 j3 you can find j4, and then j3 j4 will give you j5, etc. So starting from the basic two Bessel's function, say j0 into j1, you can calculate all the other Bessel's function using this equation. So that's why this equation is known as the recurrence relation. Okay, now here I have done the detail of the derivation of generating function from my notes, and then the recurrence relation. So this is the first recurrent relation we have discussed, and there is a second recurrence relation which is shown here, jn plus 1x minus jn minus 1x is equal to 2j dash nx. So this recurrence relation involves the derivative. So it is again a three-term recurrence relation, which means that if two Bessel functions are given, jn minus 1x and jn plus 1x, you can find the next Bessel function. So that's the proof of these two recurrence relation as done in my notes. And although my notes shown here are a bit dim, but you will get a clear photocopy of my notes from the photo state shop. Right. So here is the parity property, which is proved as I told you before, and these are the additional two more recurrence relations, d by dx x power n, and the second one, and let me show these two from the book as well. This is equation 11.15 and equation 11.17, giving us two more recurrence relations. Now the beauty of these two recurrence relations is that these are the two terms recurrence relation, which means if jn minus 1x is given, then you can find jnx. So these two recurrence relations are also proved in my notes as I was showing to you the pages, so you can go through all the